This video is on the objective use the law of cosines to solve SAS triangles. Alright, so SAS triangles, that's side, angle, side. So those are triangles where you know two sides and then the angle between them, the angle that those two sides form. So let's take a look at this first question. Again, if you want to see more about the topic, look at more instruction, look at their notes, their videos, their examples, and hopefully those can help you out. Now this is a multiple choice one, looks like. It looks like all the answers are rounded to the nearest tenth, all the angles to the nearest tenth of a degree, all the side lengths to the nearest tenth of a unit. So that's what I'll do when I go through this. So we're asked to solve the triangle, right? When you're asked to solve a triangle, that's find all the missing angles and all the missing side lengths. All right, so I'm going to draw a picture here, right? Notice that this is an SAS triangle. You know two side lengths, A to B and A to C here, and the angle that they form, right? The angle between them. All right, so I'm going to draw a picture of this and then show you how we would go about finding all the missing pieces. All right. So again, this is an SAS triangle. Side, angle, side. Alright, now I labeled these sides. Right? Remember how things were typically labeled in previous assignments. You have a triangle ABC, the angles are labeled with capital letters, and then the opposing sides, the sides opposite, are labeled with the lowercase version of that same letter. So this side here has length little a, its opposite angle big A. This side here, I'm labeling little b because it's opposite angle b. And this side here, I'm labeling little c and its opposite big C. I'm going to try my best to, make my big C's and little c's distinguishable. Alright, so we have little c is 10 units long, little b is 4 units long, angle A is 41 degrees. Now, in the side, angle, side scenario, you can use the law of cosines use the law of cosines to find the side opposite the angle. Alright, so this angle we know, we can use the law of cosines to help us find the side opposite. So I'm going to use it to find little a here. Right. So now what does the law of cosines look like? Well, take the side opposite the angle we know and square it. Right, a squared. Alright, so if I'm trying to find little a, I'll start with a squared. The other side is kind of like the Pythagorean theorem. It starts off like the Pythagorean theorem, where one side squared, a squared, is equal to the sum of the other two squares, b squared plus c squared. Alright, but this isn't the end of it. So it starts off looking like the Pythagorean theorem, but then there's a little extra term. And this extra term involves side b and c and the cosine of the angle opposite our side, angle A. So we subtract from this 2 times the product of b and c, right? 2 times b times c, times the cosine of the angle opposite this side over here. So again, if I have a squared on this left side, I'm going to have angle A inside the cosine. All right. So a squared equals, b squared plus c squared minus then this big product, 2 times b times c times the cosine of angle A, the angle opposite this side on the left side of the equation. All right, and again, we can mess, you could do all sorts, there are 3 different versions of this. We could have c squared equals a squared plus b squared minus 2ab times the cosine of c, angle C. Or you could have b squared equals a squared plus c squared minus 2ac times the cosine of angle B. All right? It all depends on what you're trying to find. So if I know angle A and I'm trying to find side A, I'll use this version where angle A is actually used. And if angle A is in the cosine, that means a squared is on this side. Alright, so let's fill in the missing pieces. Now, again, I don't know side A, so we have a squared equals, b squared would be 4 squared, little c squared, side length c squared is 10 squared, minus, and then 2 times 4 times 10 times the cosine of 41 degrees, right, my angle A. Alright, and so notice I have everything but little a. Alright, putting some stuff together over here. Now you can actually just type all this in on your calculator. Right? Just make sure you're in degree mode because my angle's in degrees. But I'm going to put some stuff together here. This is 16 plus 100. So these two add up to be 116. And then this product here is 80, right? 2 times 4 times 10. So we have minus 80 times the cosine of 41 degrees. Now be careful. I see too many people make this mistake. They subtract the 116 and the 80 and say, oh, this is 36 times the cosine of 41. No, it's not. This 80 is not separate from the cosine. This 80 is attached to the cosine. So I can't just subtract the 116 and the 80. All right, this is the way it's got to stay. Alright, then we have this is a squared. Right? I want a itself, so I take the square root of both sides, and so a equals, now I know it could be plus or minus, but since we're talking about the length of a triangle, of a side of a triangle, we're going to use just the positive square root. So the square root of 116 minus 80 times the cosine of 41 degrees. Right? And we're going to round this to 1 decimal place. Right. So on my calculator, I'll pull a calculator up. Make sure, again, I'm going to make sure I'm in degree mode. Turn it on. Alright, so I'm in radian mode right now. Let's change that to degree. And then we're doing this square root. And then make sure all of this is inside the square root, right? So we have 116, that was the 4 squared plus 10 squared, minus 80, right? That was the 2 times 4 times 10, times, and then the 80 is multiplied by the cosine of 41 degrees. So again, notice how my square root bar just extended on this. On some of the older ones, you might have to just put parentheses around both ends just to make sure this is all inside the square root. Alright, and then rounding this to 1 decimal place, that's 7.5. So back on my picture, I'll put this in red. This side length is about 7.5 units long. Okay. Now, that's one piece that was missing. Now I would like to find, the missing angles. All right, the missing angles. Now I don't only have a side angle side triangle. Now I have a side 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 triangle. I know all 3 side lengths now. So I could use the law of cosines again to find one of these missing angles. And you only need to find one of them, because once you know 2 angles, you can find the third. You also have an angle side side triangle, right, or side side angle. Now remember, that was the ambiguous case for when you could use the law of cosines, or sorry, the law of sines. So you could, if you wish, find the law of find a missing angle using the law of sines. All right, so I'm going to actually do both things. Right, I'm going to do both things, and I'll tell you which way I prefer when I'm done. All right. So now that I have A, now it's a side-side-side triangle, if you want to think of it that way. An SSS triangle, right? I know all three side lengths now. So again, a side-side-side or side angle, side triangle, we can use the law of cosines. I can use the law of cosines again, this time to find an angle. All right. Now it really doesn't matter which one with the law of cosines, because you're going to end up taking an inverse cosine, right, to find an angle. And the inverse cosine of some input will give me any angle, some angle from 0 to 180 degrees, if you remember your inverses. So it doesn't matter which angle I find. So I'll find angle B. Right? Let's say I want to find angle B. Alright, so I'm going to start off with then, if I'm finding angle B, I want to use the version of the law of cosines that has the cosine of angle B in it. And if I have the cosine of angle B on one side, on the other side I'm going to have, little b squared. So I'm using this version. Little b squared will be equal to, the sum of the other two squares, a squared plus c squared, but then more, right? Minus 2 times a and c, right, these two sides, times the cosine of the angle opposite this side, angle b, right, the angle I'm trying to find. All right, and then I'll fill some stuff in. Little b squared, that's 4 squared. Little a we said was about 7.5. All right, 7.5 squared. Now on my calculator, I'm just going to use this value here. Okay, I'm just going to use this previous value because this is little a, right, more accurately. Then we have plus c squared, right, plus 10 squared, minus 2 times 7.5 times 10, and then times the cosine of angle B. Alright, so what I'm going to do here is solve for the cosine of angle B. Alright, get the cosine of angle B alone. So if I do that, well, this is all one big term over here. This is this big product. I could add this, subtract 4 squared, and then divide by the stuff that's not cosine B. So hopefully you can follow the algebra. I'm not going to write all those steps. And get the cosine of B equals, 7.5 squared, that was little a squared, plus 10 squared, then minus 4 squared, all of that divided by this product in front of the cosine. Again, I added this, and then I'm going to divide by that 2 times 7 little a times little c. All right, 2 times 7.5 times 10. And then to find angle B, I take the inverse cosine. Right? So angle B is the inverse cosine of this expression. Right? I'm not going to write it again. All right, and we're going to round this to 1 decimal place. And again, make sure I'm in, all my angles should be in degrees here. I'm in degree mode. And I'll do this, right? We go inverse cosine. And then you have a big fraction here. So I'm going to put my numerator in parentheses. So in parentheses, we have, now I'm not going to use 7.5. I'm going to use the previous answer, this 7.45, blah, blah, blah. So I'll go second answer, that number squared, plus 10 squared, right, so plus 100, minus 4 squared, right, so minus 16, close the parentheses on the numerator, then divide that by, and then I've got a product in the denominator. I'm going to put parentheses around that as well. So parenthesis 2 times 7.5, but again, I don't want to use 7.5. I want to be more accurate, so I'm going to use this value here. So again, previous answer times 10. And then close the parentheses, close them again, that'll close them all. And here we go, approximately 20.6 degrees. Approximately 20.6 degrees for angle B. All right, so I'll put that in my picture. So this angle here is about 20.6 degrees. Wonderful. Now the only missing piece left is angle C, which should now be very simple. All right, when you know two angle measures, you can find the third one no problem, right? Just subtract the other two from 180 degrees. So now if I want to find angle C, just take, C would be equal to 180 degrees minus the 41 degrees for angle A minus the 20.6 degrees for angle B. All right. And if I go, I can go on my calculator, go 180 minus 41 minus, and then I'll just, instead of 20.6, I'll put it, I want to be a little more accurate. I put in this previous answer, and it's about 118.4. Now this is 118.4, but you know, I could have done that without, because this is 61.6, plus 118.4 would be 180. So in this angle here is approximately 118.4 degrees, and there you go. You have solved this triangle using the law of cosines. All right, great. All right, so back on my, now like I said, I'm going to go over that another way, a way I kind of actually prefer. But back here, that is A is 7.5, B was 20.6, and C was 118.4, so this option here. Okay. And again, they go through all the same calculations I just showed you, but they use the law of sines. All right. Now, I want to tell you to be careful with the law of sines. All right, let me show you the second way to do this, the way they're showing you. So this is an alternate method. So first I use the law of cosines. Right? First I find the side. All right, so I found A using the law of cosines. And now I can think of it, after I use the law of cosines, now I can think of it as an angle. All right, so again, I only know this one now. All right, we don't know, let's say we don't know the angles anymore. Now I can think of this as an angle side-side or a side-side angle triangle. And remember, when you have these side-side angle triangles, right, side-side angle or side-side angle, you can use, I'll say you can, you don't have to. You saw that you don't have to. But you can use the law of sines now if you wish in that side-side angle case. But be careful. All right. So method 2, I guess, using the law of sines. Oops, law of sines. I have a warning. Right. We saw already that one of these angles was obtuse. Right? The angle C is 118.4 degrees. If you were to use the law of sines to find angle C, you wouldn't get 118.4. Because remember, when you're solving for an angle measure in the law of sines and you end up taking an inverse sine, the inverse sine of some number, the highest that can be is 90 degrees. Remember, the range of inverse sine was negative pi over 2 to pi over 2, or negative 90 degrees to 90 degrees. So I would say to you, after you've used the law of cosines to find little a like this, so here's a note for you, a hint. After using law of cosines to find one missing piece, right? So after using law of cosines to find, one missing piece, right? This is that opposite side. Use the law of sines find the smaller remaining angle. Okay. Because the reason I say this is because the smaller of the two remaining angles can't be obtuse. Right? You can't have more than one obtuse angle in a triangle. And then the inverse sine would give it to you. So remember how you find this. Remember that, again, say I don't know 20.6 and I don't know this. Look at the opposite sides. The side opposite angle B is shorter than the side opposite angle C. That means angle B is the smaller of the two missing angles. Alright, so then I'll go finding angle B. Right, find B. And we'd have the sine of B divided by 4. Right, the sine of B divided by little b would be equal to the sine of, now I know side A, and I use the sine of 41 degrees divided by side A is, approximately 7.5. Then I'd multiply by 4. So the sine of B equals 4 times the sine of 41 degrees divided by 7.5. And then take the inverse sine of this. The inverse sine of this expression. And let's see what we get. Now I'll use the rounded version because it's been a while. I don't have that same thing up anymore. So I'll take the inverse sine 4 times the sine of 41 degrees divided by 7.5, and hopefully this rounds to 20.6. And it doesn't. Reason for that is because of the rounding. So let me do this instead. 4 times the sine of 41 degrees divided by, and then I'll go up here to that 7.45 blah 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 and enter that, and then take the inverse sine of this with a more, this should be more accurate. You see 20.6, that's much better. Right. So really I used 7.458 dot 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 7.45, the more accurate answer, and that gave me the 20.6 degrees that I wanted. Alright, which was what we found earlier using the law of cosines. And then once you know that's 20.6, then you'll know that's about 118.4 and you're done. Okay? But yeah, so in this side angle side case, if you want, after you use the law of cosines to find that missing side, then you can use the law of sines if you want to find these. I would recommend doing it with the smaller remaining angle. Because if you do the larger one, that might be obtuse, and the inverse sine doesn't give you obtuse angle measures. Okay. So either way is fine, though. Either way is fine. You can use, like I did here, you can use the law of cosines to find angle B as well. All right. But you can also use, the law of sines if you wish, after you find that missing side in this side angle side case. All right. So hopefully watching me do this here. Looking at more instruction if you need to, reading the answer explanations when they come up. Yeah, see, they didn't use 7.5 here either. They used 7.4581. Hopefully looking at all this stuff helps you when you go about doing this work on your own. Thank you very much for watching.